Okay, so let's talk about everything you guys discussed. So who do I want to start with? All right, Philip.
The green dot.
What's the green dot called? Good job. Let's hear it. Carrie. Where would you locate the vertex? The blue dot. Really technical knowledge right there, right? The blue dot. That's what we're going to call it. The blue point. Okay, Allison? The red line is the directrix. Good job. Straya? The vertex, the distance from the vertex to the focus is P. Good. Let's hear it. Kayla. In order to get the LLR, we times P by 4. That's skipping a step for me. How about the distance from the vertex to the directrix is also P. Allison, you want to expand? The distance from the focus point out to the outer edge of the parabola. Good job. We're not going to put a bracket for that one. We're just going to put 2P. Then we can say what Kayla said, the distance of the LLR, or how wide my parabola is 4P. Well done, guys. So if you need to add any of that to your notes, there's one more thing that we did. I'll do it in black. It's kind of given that since we have 2P and 2P, that the distance from the directrix to the focus and the focus out to the parabola is the same distance, right? But the definition of parabola is that we could do that with anything. So no matter what, if I want to go out to a point, let's say, let's use an actual line, but let's change my color to black. So if I want to go out to here, right here, shouldn't my distance from this point to here be the same? So couldn't I take this? Thank you so much. That would have been bad. From our focus out here, I would have made all this whiteboard magic and then it wouldn't have worked at all, right? So if I take this line and copy and paste and rotate it, and I just messed up. Come on, where are you? And rotate it to 90 degrees, it should be the same distance. Isn't that cool? So no matter what, no matter where I am on my parabola, if I go from my focus to any point right there, that distance from there to there is going to be the same. And that's what you guys did with that folding activity, right? That's what you were doing. You were making a whole bunch of folds that were equidistant. Okay, cool. Yes? No. The only time it's 2P is when we're talking about going through the vertex. So exactly symmetrical, right? So this is 2P and this is always going to be 2P, no matter what. But as soon as you start going out further, it's no longer 2P, right? Because we're coming from this angle here. But if you go from the very, very center, then it is going to be the same. We don't know the length of the black lines, but we do know that they're congruent. They're the same distance. They're equal, right? So I can't measure them, Allison, but I can tell you for sure they're the same if this is a parabola. So that's kind of what we're getting from that. But that's a really good question. I love it. All right, so let's keep going. So which ones are parabolas? Discuss for 30 seconds. Okay, in 5, 4, 3, 2, 1. Okay, I heard Lucas say something. What did you say, Lucas? The balloon one and the Grand Canyon one are the only ones. So what made you say that? Just the other ones are straight lines down. They're not parabolic, right? So like if I were to, I know for sure that this one isn't. Because all that is, it looks like a semicircle on top of a rectangle, right? And that's not a parabola. Same with this one and the house, right? So I know for sure. But the only way I could tell this one right here is if I actually knew where the focus was. You'd have to know where the focus is and be able to measure it because you'd have to have a directrix, right? And then you'd have to measure it to the focus, and it would have to be equidistant. These two would have to be the same. Correct? We can't really tell because we don't have a directrix and we don't have a focus. It could be a circle. And the balloons? We don't know with the balloons. We don't know with the McDonald's unless you were to actually measure it. I don't know if this one is or not. Right? It looks like it. It could be. Mommy, I'm wearing shorts and a tank top because it's sunny outside, right? What about these two? Okay, so Carrie has something to say. Let's see what Carrie has to say. They're normally parabolas, right? So if that's a satellite dish, they're usually pretty mathematical, right? So they're probably going to use, I would say that I would look at it like this would be the vertex, this would be the directrix, and probably the focus, right? I don't know. It's not accurate. I'm just saying. Okay? Are you guys... I don't know if this is the focus or is the focus like inside right there, and then this is the LR. I don't know, but I do know that it's actually inside. Very good. I love it. I think we should watch a video tomorrow about it. Yeah, we'll do it. Okay. In 5, Lucas says we should discuss it over pizza. In 5, 4, 3, 2, 1. You guys are getting better at that. All right. We're not going to go into this. Okay. Flashback. So this is what we were doing yesterday. I would like you guys to discuss with your tables, and how about spades? Tell me what P is. Tell me what P is. One. Okay, so as I walk around, I can see that almost everybody agreed that it was 2. So Treya and Philip seem like they are anxious to tell us how they figured this out. So let's listen to what they have to say. How'd you figure out P? P is the distance from the focus to the vertex. So if this is P, how many units is it? But what would you do, Philip, if you didn't have a picture? What if I had no picture of the parabola? Tristan, you want to explain it to me what you would do? Why? Okay, so Tristan would take the coefficient of y, Lucas, and he would divide it by 4 to get p. How many of you did it that way? Okay. Who did it a different way? First, let's go to this. Where is the parabola 8 units wide? Oh, Sarah, I loved that vocabulary. Can you say that just a little bit louder for me? Horizontally through the focus. Said perfectly. It's 8 units wide right there. Right? So can anybody explain to me how they found P using that piece of information? Florencia. But if I didn't have a picture of it, what if I didn't have a picture? Kayla? Well, we already got that way. Does anybody have a different way? You guys all got 2p and it was just from counting? Nobody else did it a different way? Wait, Rain, what did you say? Oh. Was it Kellen? The easiest way would be to look at it. Philip? You want to try? Breezing through it, though, rather than just dividing. Okay, so let's start with the 8. So 4p is 8 units. Then what would I do? What? Okay, so if I know that from here to here is 8, then half of it is going to be 2p would be 4 units, right? And I just happen to know that this distance here is going to be the same as this distance here. So if I want to know not the whole distance to directrix, but just half of it, I'd half it again. So 1p, equidistant, thank you, is 2 units. Thumbs up, thumbs down. Awesome. Tarsa, thumbs up, thumbs down. I scared you, didn't I? Okay. I'm wondering, did you guys see the relationship here that Tristan was talking about? The coefficient of y is 8 units. It's the same as how wide my parabola is, 8. So let's use that piece of information. Can you tell me what p is with this one? Go.
I don't know how to do it with this.
All right, in 5, 4, 3, 2, 1. I want to hear from somebody else. We are recording, right? Perfect. So who has not spoken yet would like to explain to me how they figured this out? Sarah? Yeah. Explain. So you took 2 and you divided it by 4, which equals 1/2. Did anybody do it a different way? See, that's why we're going to talk about it in a different way, because not everybody understands that we're dividing by 4. Allison? 4p equals 2 units, okay? 2p equals 1 unit. Half a unit, right? Do you want to write it as a half, or do we want to write it as a decimal? Both? Okay, we'll put 0.5 there, and we'll write 1/2 here. How's that for a settlement? Well, we have both, right? Okay, you guys ready for another one? Yes, Mrs. Muller, we can't wait, right? What about that one? Like it. Yes, I can. In 5, 4, 3, 2, 1. Is there another brave soul that'd like to speak besides Philip? Oh, let's hear it, Dylan. Why is it 1/4, Dylan? Because you said so. Can you explain yourself, please? There's a 1 in front of the Y, which is very important. Then what? So if I divide by 4, it's 1/4. Perfect. Pretty simplistic. Let's do it in a different way. I think Philip's met his quota today, right? Okay, Allison. Let's go with Allison. 4p equals 1. 2p equals a half, or 0.5. So 1p equals 0.25. Good. You guys ready for another one? Okay. Let's keep it quiet for a second. Philip, what's your other way? Okay. We'll let you share it on this next one if it works. How about that? How about that one? All right, in 5, 4, 3, 2, 1. Okay, Philip, I promised you. So you know the whole distance is 6. I like it. You know half of that is 3. You read my mind. Yes. So this is also 3. Yes, and then what? And half of that. That's exactly how I do it, Philip, in my head. So that would be 3 halves. Or you could think of it as cutting 3 in half is 1.5. Okay, I'm just curious, guys. You guys tell me with your red or with your green. Did you divide by 4? Or did you cut in half and cut in half again? Let me see if with your response 6. Dylan, that is not fair. Let the rest of your group vote. Oh, you all agree. Okay. Let's see it. Oh, some of you are in the middle. Brain's not making a decision, right? He's going back and forth. Okay, thank you. All right, guys, I'm going to move you on. So let's think about this. Everybody pencils down. Response 6 down. Okay. So this is one of the problems, Trey, I need your attention. This is one of the problems that we did yesterday, only I didn't give you the formula. Okay? So yesterday we found that P was 4 because we graphed the focus. So here's the focus. And then we graphed the directrix. And we realized that our vertex has to be right in the middle. Remember that? So then we counted, well, then that means P must be 4, and P must be 4, and 2P must be 8, and then all the way across must be 16. Okay? So my vertex happens to be at 1, 0. So let me write that one too. My vertex, we'll add it in here. My vertex is at 1, 0. So can you relate the information from your graph to the equation? Talk that out. And, all right, what did you guys come up with? Can I get it? Besides Philip? Allison said a lot too. I should draw cards. Let's draw cards. They are. Ooh, Rain's the first one. Rain, what did you come up with? Just give me one piece of information that you came up with. That's exactly right. The K and the H are the points that are the vertex, right? So here, what we've been learning all along since the beginning of the school year almost, well actually not, we did the arithmetic and geometric, but since we've been working with absolute value graphs, didn't we always say that this right here is my horizontal shift and this one is my vertical shift? Therefore, 1, 0 is my vertex, and I'm over 1, 0 right there. So what other piece of information, what is the only other piece of information that this formula provides you? What is, I heard Sarah say, what does the 16 mean? It's the LLR, right? The length of the lattice rectum. It's 4P. 16 is 4P, right up here. See this, Sarah? 4P is 16. See that? See that? There's only one more piece of information that's not up here, but it is. And it's right. You ready for it? Ready for it? Why does it have to be positive, Philip? Oh, I'm so sorry. I'm wrong. It has to be negative. And it has a maximum. Why does it have to be negative? Because the parabola is pointing down. It's pointing down. Right? You guys ready for another one? I don't think how much time are we? We've got a lot of time. Okay, so let's start this one off together, and let's make our way to the equation. Lucas? Okay. Lorenzo? All right. So let's make our way. So if my vertex is already at -2, -1, I'm going to go ahead and just write myself out here. Like kind of like a skeleton of what my equation should look like. So my skeleton should have whether or not it's positive or negative, what my LLR is. It's going to have y minus something equals x minus something. Right? Doesn't that look like this? Right here? All right, so I want you guys to work together. I want you guys to come up with that equation together in groups. I'm going to give you 2 minutes. All right, so I'd like to share something that Rain came up with. He came up with, Mrs. Mahler, you forgot the square. Why isn't the square over here? They're not both squared. Why does x get to get squared and y doesn't get to get squared? Talk about that together. No, talk about it. Talk about it. Okay, no, it's okay. All right. Let's, Shreya, you want to explain?
X squared because it opens up and down, and with y would be squared if it opens 5.
Wow.
Because it's the parent graph, it's x that is symmetrical on the y-axis. It's x that's symmetrical. X is being squared. If it was pointing this way, it would be symmetrical. The y would be the part that would be symmetrical, right? And it would be y squared. We won't get there until Monday. All right? So we're just going to talk about x being squared right now, but I thought that was great that Rain came up with it. Okay, so let's see. How about Carlos? Carlos is not in this class. So these cards are mixed up. Sydney. Sydney, can you give me a piece of this information up here that we're missing? We're missing a whole bunch of stuff. We're missing P. We're missing LLR. We're missing the equation. The LLR?
Yeah.
Okay, the LLR is 16. She says the LLR is 16. How did you get that piece of information? You guessed. You guessed. What do you guys think? Christina, isn't it 12? Why did you say it was 12, Christina? Wait, hold on. Christina's talking. Because the what? So the P from the vertex to the directrix is 3. So then we know 1, 2, 3. We go 3 more, and we would get to the focus. So our focus is at -2, 1, 2, 3, 4. -2, -4. I didn't even put focus up here. Focus is -2, -4. And that would make our P, like you said, is 3. Fantastic. And then what would you do? Now that we know this is 3 and this is 3. So how far do I go out from the focus? Good. 1, 2, 3, 4, 5, 6. And I go out this way 6. 1, 2, 3, 4, 5, 6. For a total of 12. So that's where we got our 12 from. And then I could graph it. What are we left with? So what piece of information can we put in here? Okay. Let's hear it. Allison? Okay. The 12 goes in front of here. Let's change our color, though. Okay, so if you don't raise your hand, you shouldn't be talking right now, right? Lucas? Oh, that was Angie. Was it Lucas or Angie? Okay. Lucas, add some more information. You're talking, so I figured you had more information to give me. You didn't. A negative sign. Good. That's perfect. We've got a negative sign because it's pointing down. What else? Let's see. How about... Okay, Rain. Put a 1 for the y. You have to add 1. Why are we adding 1 for y? So you're telling me that my vertical shift is down 1, so this should be positive 1, right? Because it's opposite? Perfect. What about my horizontal shift, Rain? What's my horizontal shift? It's to the left 2, so this is going to be plus 2. Good, because you have to set them equal to 0. Philip wants to give me all the insides because he knows what he's talking about. Yes, Sydney. You don't need to know your zeros because actually, are there zeros? There aren't any zeros, right? So actually, if you were to FOIL this and put it in standard form, you would not be able to factor it, right? Not only that, you wouldn't be able to factor it. Could you use the quadratic formula? You could use the, what would you get? What kind of roots would you get? Let's hear it, Carrie. Complex roots, right? Imaginary roots. If I completed the square, wouldn't it look something like this? Let's do this. I'm so excited. If I were to complete the square from the original equation, which we don't have, wouldn't the answer be x equals -2 plus or minus, I don't even know. If this was 1, wouldn't it be I? Because 1 squared is I, and that would be how far you would go, right? Am I right? I would be right, huh? Do you see it? Because we would take the distance away from, because if this is 1, if my vertex would be 1 away, then wouldn't my distance have been 1 away? So it would have been 1 squared, which would have been I. I'm working backwards on it. You don't have to do that. I'm just saying, if I had the regular equation, do you see how it's all relating now? We're not going to do that. Don't worry about that. But I'm just saying. Okay, let's keep going. So now let's start the lesson.
Okay.
Okay. All right. Okay, hold on. 1 second. Guys, all we're going to do is work the other way around. So I'm going to give you the equation, and you're going to graph it. So that's all we're doing that's brand new. But the only difference is we're going to use some of those. I'm going to do the hardest ones first, and you guys are going to do the easiest ones for homework. Okay? All right. You're going to hold on. Oh, guys, you're wasting my time. Hold on. So let's describe what's happening horizontally and vertically with this one. So I would say horizontally has to do with x, right? Horizontally, we are going -2. No, we're going sorry. Going that way, we're going this way. We're going -2. Vertically, Parsa, sit up. I know you're paying attention, but vertically, what are we doing? We're going down 3. What are we doing with our 8? It's 2, or P is 2, you're right. But it's out 8, right? And it's going up. That's what we could say about this graph, just by looking at it, right? Let's look at this one. So write on your desk right now what your vertical translation, what your horizontal translation will be, and whether it's pointing up or pointing down. I'll get you another marker. Okay. So I'm going to say my horizontal change is going to be 5 to the right. My vertical change is going to be 1 up, and it's going to be pointing down. Do you guys want one more? Yes, process it. Okay. Do you guys just want to move right into the problem? Okay. All right. 5, 4, 3, 2, 1. So just by looking at this, I should be able to say to myself, this is Mahler. This is a graph that's pointing down, right? It's a parent graph that's pointing down. But we're going to be a little bit more specific than that, right? So first of all, I'm going to want to put in my horizontal and my vertical change. So my vertical change is, it's not changing at all. And my horizontal change is, it's also not changing at all. And technically, I'd like to put that negative over here. If I divided both sides by negative, I would say this would be transformational form, and I would have every piece of information that I need. So my translation is, I'm not going to be going anything. I'm not going to be going at all on my horizontal change. I'm not going to be going anything at all on my vertical change, and it's going to be pointing down. Okay. Kayla? It would be negative 4. If the y had a 4 in front of it, it would be negative 4. I just said that there's no vertical change. Since there's nothing associated with the y, so you're saying if this had a 4 in front of it, it would mean it's 4 wide. You'd have to have something after the y. Good job. Okay, so let's talk about this. So my vertex, I can already see my vertex already. My vertex is here and here. 0, 0. All right? I'm not even going to graph yet. How wide is my parabola? No. Where do we normally find how wide it is? Not in front of the x. It's in front of the y. It's not an example. It is the standard equation for transformational form. So 4p does equal 1. So if 4 p's equal 1, how much do 2 p's equal? 0.5. And how much does 1 p equal? 0.25. Right? It doesn't have to be negative, Kayla, because we know it's going to point down no matter what. Got it? So you don't really have to use that negative sign. You just have to know, hey, that means I'm going to be pointing down. Okay? All right. So that being said, so if my vertex is at 0, 0, and my p, Lucas, this is really important, this part, okay? So I don't want you to miss it. So if my p is 0.25, aren't I going to be counting by quarters? So shouldn't I make my graph look like quarters? It would make it easier to graph, right? Well, I'm going to be counting p. Got it? No, not the actual coin. I guess we could technically put quarters up there, right? I'm going to have to do that now just for Angie, and then she's going to laugh, right? It's going to have like quarters, a quarter, and a quarter, and a quarter, and a quarter. Okay. Okay, so I'm going to count by quarters. 1 quarter, 2 quarters, 3 quarters, $1. 1 quarter, 2 quarters, 3 quarters, $1. 1 quarter, 2 quarters, 3 quarters, a negative $1. 1 quarter, 2 quarters, 3 quarters. Lucas, as much as I appreciate you and your participation, could you be quiet, please? Okay, that's the nicest way I could put it. Okay, so my vertex is at 0, 0. P is 0.25, so don't I have to go up or down to get to my focus? Philip, here's my parabola. If I have a focus, is my focus on the inside or on the outside? It is? It's out here? On the inside. So if I know it's on the inside, I'm not going to go up to get to my focus. I'm going to go down to get to my focus. So my focus is, no, I'm not going anywhere on the x. I'm just going down on the y. So my focus is at, we just need some more, let's see, enter, that's good. Thank you. Uh-oh, I lost my focus entirely. That's okay. All right, so my focus is going to be at 0, negative 0.25, or you could write negative a quarter if you wanted to. So then my directrix would mean I'm going up a quarter. So if I'm going up a quarter, what's my y going to be? Y equals 0.25. 0.25. So all we need, oh, we already had our equation. We're going from the equation. I'm thinking of yesterday. So I got everything I need. Oh, I'm not done. What am I missing, Parsa? The parabola. So how can I figure out how wide to make that parabola? The LLR, right? We have to figure out, isn't there something on this equation right here that tells me how wide my LLR is? It's 1, right? Not -1, because we can't go -1 distance, right? It's just 1. So if I were to start here at my focus, because my focus focuses on how wide it is, right? So how wide is it going to be? 1. So am I going to go all the way out to 1? Really? Because then if I go all the way out to 1 this way, I would have a total of 2, and we don't want 2. We want it to be 1. So how far am I going to go? I'm going to go out 0.5 and out 0.5 to make a total of 1, right? Is that a total of 1? And that's all we need. How are we doing on time? Pretty good. All right. I'm going to fast forward. So what's the difference? Let's just talk about what's the difference that this is. So 30 seconds, talk at your table. What's this one? How is this one going to look different? 1. All right, what'd you guys come up with? What's the translation going to be? Is it going to be pointing up or pointing down? It's going to be pointing up because this is positive. Positive 1 to be exact. Is it going to be going horizontally at all? So it's not going to go horizontally at all. Is it going to be going vertically at all? Up or down? Up 2, because this is a translation of 2. Perfect. And then, let's see, so my vertex is going to be, if I have 0 horizontal translation, 0, and I have a vertical translation of 2, it's going to be at 0, 2. But since it's 0, 2, hold on a second. If my LLR is 1, what's P? 0.25, right? If 4P is 1, then 1P must be a fourth. But if I were to count by fourths right now, guys, 1 quarter, 2 quarter, 3 quarter, 4 quarters, do you see that I can't go 0, 2 because it'll be off my graph? So I'm going to count by not quarters, but I would count by halves. Let's make this 2. So half 1, half 2, half 1, half 2, half 1, half 2. All right, so I'm going to do this pretty quickly because I want you guys to be able to get to the last one. So I was going to go over 0, 2, so 0 up 2. I'm going to go up a quarter to my focus because it's going to go up, and I have to go down a quarter for my directrix. Remember, these are halves, and I need to go a quarter, so I'm going to go a quarter, and I'm going to have to go out 1 for my vertex. So out 1 would be a half and a half. So here and here. I want you guys to at least get, okay, Dylan, I'm going to pass them out. I want you guys to at least get to here on your homework. This is the hardest one of your homework. All the rest of them don't have any fractions. It's all going to be whole numbers, so you won't have to worry about it. Actually, I lied. There's 2 of them. You guys tell me, as your homework's coming out, is this going to be pointing up or down? Down. But there's something different about this one. Everybody look up here as your homework's coming out. Freya? What's different about this one from this one? You have to move the 6. When you move the 6, what happens to it? No. What happens to the 6 when you move it over? It's negative 6. You subtract it. But what's going on here? That doesn't look like that. So what could I do? Factor out negative 2, and I would have y plus 3. Now does it look like you need it to look? So make sure you have that on your homework. So it's pointing down. How did I get to what? Are you guys good? So I had to factor out a 2, and I got to check it. Negative 2 times y is negative 2y. Negative 2 times 3 is negative 6. So I knew I did it right. If you don't like factoring out, you could divide by negative 2 and divide by negative 2 if you wanted to. So what's my horizontal shift, guys? Hold on. What's my horizontal shift? 1 in which direction? To the right. And what's my vertical shift? Down, negative 3. Good job, guys. That's all you need. See you tomorrow. You're welcome.